Well, hello. We're ready for the review for the Exam 3, which will be our final exam of the semester. So I have the 18 question review packet, and I'm going to work through each of the problems. We've done some in class already, but we'll just go start to finish and cruise on through these. So to start with, we want to construct a graph for each of the following settings. So let's kind of make it kind of nice. Let's go with red. So actually I'm going to put all of these on one graph. So here's my y-axis and here's an x-axis. This first one, a linear with positive slope. Let's do that in yellow. So it would be any kind of a line that is going upwards. So there's a positive slope. Going from left to right, it's going up. So that one is A, line A. So line B, a linear with a negative slope. We'll do that when we come from left to right. We're going to be going downhill. So any of these like this, these are all negative slopes. So whichever one you want. There we go. So line B is one with a negative slope. A linear with undefined slope. Well, we could just take the y-axis. It's a vertical line. Undefined slope is going to have a vertical line. So I'll put another vertical line over here, anywhere that you'd want to. So any vertical line is going to have undefined slope. So that'll be C here. I'll just put it's a vertical line. All of these are just here, so we won't ask you these questions directly on the final exam, but understanding them will help you solve the problems that we're going to be dealing with. A linear with slope of 0, well, that would be our x-axis, or horizontal axis, because a 0 slope gives us a horizontal line. So anywhere you could put a horizontal line, that would represent something with 0 slope. So here's a pretty good horizontal, and so we'll come back and linear with slopes. So this would be D. Running out of colors. Let's go. Call this one D. Now, nonlinear increasing. Nonlinear just means it's not a straight line, so it would be some sort of curve going up. A nonlinear decreasing would be some sort of curved line going down. Anything like that. Okay, so that's our answers for question number 1. Let's go ahead and take a look at number 3. Okay. Actually, I meant we'll be back to do question number 2, not 3. So let's go ahead and do this. Determine the slope of the line. Now, one way to do this is if we get it into slope-intercept form, which is y equals mx plus b, so a number in front of the x and a number by itself. This m is going to be the slope, simply put. Now we can also have it y equals b plus mx, and again the m, the number in front of the x, is also the slope. So we could do it either way. So with that in mind, actually I'm going to jump to b and look down here. It's y equals 1/2 x plus 3. There's our slope right there. 1/2. Just like that. All we're doing is recognizing it. Now here we look, and the number in front of the x is a 3, but it's not in our slope-intercept form of the equation. It's in what we call the general form. So what we're going to do is we're going to solve it for y. We're going to get y equals the other stuff. And the way we do that is we have this 4y here. We need to get the y by itself, so we need to get the 3x away from this side. Minus 3x from both sides. So on the left side, this becomes 0, so all that is left is 4y. The other side, we can write that as 12 minus 3x, or negative 3x plus 12, however you'd like to do it. I'm just going to go with this route. And then the last step is to get the y by itself, is we have to divide by 4, because 4 divided by 4 will be 1. On this side, when we divide, that distributes over subtraction. So the 4 has to distribute to both of these terms. And so what we end up with is we end up with y, the 4's have canceled. 12 divided by 4 is 3, and then we've got a negative 3/4 x. And this negative 3/4, that is what the slope is. Getting it into the y equals mx plus b. Now, again, you could have written this, it would be exactly the same thing as y equals negative 3/4 x plus 3. Exactly the same meaning, same slope. Okay, that's number 2 for us. So let's take a look at number 3. We're right there. So let's go ahead and go at number 3. We're given this table, the following table determined, and then we're asked to determine if the table represents a linear function, and then explain how we know. A linear function would be a straight function, and the way this happens is that the slope between any two given points, the average rate of change between any two given points, is the same. And so the way we sort of do this is we just look at each pair of points. So we look from 3 to 5, 3, so 5 minus 3 equals 2. And then we do the same thing over here. We could do 12 minus 7.6. That gives us 4.4. So the slope is the change in the y over the change in the x. So this is the x column, this is the y column. So these first 2 points give us a slope of 4.4 divided by 2, which is 2.2. Okay. We look at the next 2 points, or connecting the two, so 5 to 8 and 12 to 18. So we take 8 minus 5, that gives us 3, and we take 18.6 minus 12, that's going to be 6.6, giving us a slope of 6.6 divided by 3. Take 6.6 divided by 3, you also get 2.2. So it's looking good so far. The slopes are the same. Let's keep going. 8 to 11, and then 8.6 to 25.2. So this gives us 11 minus 8, which is 3, and 25.2 to 18.6, that's 25.2 minus 18.6, that's also 6.6. So again, we get 6.6 over 3, which reduces to 2.2. So far our slopes are checking out. And just keep checking each one of them. I'm running out of space, and so I'm just going to jump down to this last one. Let's check this last one. 17 to 20, that's 3, right? 20 minus 17 is 3. 45 minus 38.4. That results in 6.6. And so we get 6.6 divided by 3 is 2.2. I guess I've done all of these. We could check the 11 to 7. That might be the trickiest one of them all. So let's go ahead and do that. 11 to 17. So that's 17 minus 11. That gives you 6. 38.4 to 25.2. 38.4 minus 25.2. That's 10. 13.2. Wait, 10, that's 25, 26, 27, 28. Okay. I've been working on videos all morning, so I'm just going to, it should be like 12.2 or something like that. Is what I'm expecting, and it's not coming up with what I expect, so let me just do the math this way. 38.4 minus 25.2. 13.2. Okay, that's what I kept coming up with. Probably it's right. And so to get the slope, we take 13.2 divided by 6. Divide this by 6, and we got 2.2. Okay, so slope is 2.2. So notice slope, slope, slope. The slope is always 2.2, so that's how we know it's linear. And again, that's really all we need to know is how to do these, and we'll be fine. Let's go to 4. So on this one, the question, Uber charges you $5 to pick you up, 25 cents per mile. Lyft charges you $6 per pickup and 20 cents per mile. We're supposed to write a system of equations to represent this situation, then determine the break-even point, the place where they're basically both equal. Well, for Uber, we would have, it's a linear function, the cost, and again, all of this test is going to be a linear equation, y equals mx plus b. So we have a starting value, we have a rate of change, and we have an output. And in this case, the input is going to be how many miles we travel. So for Uber, we're going to have y equals $5 for the pickup plus 25 cents for every mile. So 25 cents is 0.25 times x, and x is your miles. Y is going to equal your cost. For Lyft, you're going to get y equals, this time to pick you up is $6, but they charge you less per mile, 0.20 if you want, or just 0.2. So what we want to find is where the break-even place. Obviously, or I don't know if it's obvious, but since Uber charges less to pick you up, they're going to be the cheapest if you go fewer miles. For more miles over a certain point, it's going to be Lyft because the cost per mile is less, but they charge you more to pick up. So notice both, we're looking for the place where the cost is the same, the y values are the same. So we're looking for where does y equal y. So we can put in the right-hand sides. What we need to solve is the equation 5 plus 0.25x. When is that equal to 6 plus 0.2x? Okay. And multiple ways we can do this, but we've done these before. I think as far back as Chapter 4. We've got an x on both sides, so we might want to just subtract 0.2x from both sides. I think in class we subtracted 0.25x from both sides, and that would be fine too. So here we get 5 plus 0.25 minus 0.2 is going to give us 0.05x. These cancel each other out, so we've got 6. And now we want to get x by itself, so we will subtract 5 from both sides. Five minus 5 cancels. I'm going to just keep going down and then we'll deal with it later. 0.05x is going to be equal to 6 minus 5, which is 1. The last step is all we've got to do is divide both sides by 0.05. Divide this side by 0.05. And what we get is that x, these cancel, 1 divided by 0.05. This is the reciprocal of 0.05. I think it's going to be 20. But if you're not sure, let's just take a look. Oops. 1 divided by 0.05. It is. It's 20. So what that means is that's 20 miles is the break-even point. So this is our system of equations, 2 equations to get it, and this is our solution of the break-even point. So if you're going 20 miles, call either one. If you're going 25, call Lyft. If you're going 15, call Uber. Okay. Let's take a picture of that. Let's give ourselves a little bit more room. I'm going to move 5 up. So this is a similar type problem, and actually we've already got most of it set up. So Uber charges you $5.25 per mile. What is the cost for a 12-mile trip? So as we saw before, y equals 5 plus 0.25x. I like to look at my 5. There we go. And we're going to go 12 miles, so that means that x equals 12. So we plug that in for x, and we now have y equals 5 plus 0.25 times 12. We're going to find that the cost is 5 plus 0.25 times 12 is $8. Cost. Remember, on the test itself, it'll be multiple choice, so you just have to circle the correct answers. You just need to know how to do them. Okay, let's go ahead and take a picture, and I think we have enough room here. The candy machine makes 26 candies every 3 minutes. The holding bin has 52 candies in it. Right now, write an equation that models the amount of candy in the bin after X minutes. You then use your model to find the number of candies in the bin after 27 minutes. So X is equal to minutes. Y must be the number of candies in the bin. Number of candies. Okay. So the number of candies in the bin is equal to the number. Remember, it's always y equals mx plus b. B is the starting value. It's the vertical intercept. M is how it is changing. X over y. Y over x. So what do? We start with 52 candies. There's already 52 in there. That's cool. And what we're going to do is we're going to add 26 candies every 3 minutes. We're going to add 26 candies every 3 minutes. And we multiply by minutes. So after 3 minutes, 3 divided by 3, we're going to add 26. So there's our equation. That's the model. So write an equation that models this. That's sort of the A part of this question. The B part is, after 27 minutes, how many candies do we have? Well, that's taking 27, plugging it in for x. So the B part, we've got we're going to have y equals 52 plus 26 over 3 times 27. Now, if you'll notice, 3 goes into 27 9 times, so it's 9 times 26 plus 52. Makes we didn't have to go to any decimals. So come here. So we just take 9 times 26 equals that, plus the 52 we already had, 286 candies. All right, that's 6 of the problems. Let's go ahead and record that. Cancel that out, and then we'll move on down to number 7. 7 and 8. Put it right here. Graph of a linear function has an x-intercept of 12, a y-intercept of 2. Determine the slope of the line. So if its x-intercept is 12, what does that mean? It means, remember, an x-intercept has a y value of 0, and the x is the x, so that's 12, 0. It's going through the point 12, 0. The y-intercept means x equals 0, so I'll put that here. This means y equals 0. So that means we have a point with x equal to 0 and y equal to 2. Now we simply find the slope. So the way we find slope is we subtract one point from the other. So 12 minus 0 is 12. 0 minus 2, 0 subtract 2 is going to be negative 2. And then we just simply take the x, tuck it underneath the y, and there's our slope. Negative 2 over 12, which reduces down because 2 goes into both of these, to negative 1/6. Just like that. But using the definition, what an x-intercept is. An x-intercept is a place where y equals 0. A y-intercept is a place on the graph where x is 0. X will always be 0 if we have a y-intercept. That's how we're going to answer a lot of these questions that are going to be coming up. Okay, take a picture of that one. Now for 8, from the information given in the table for problem 3, determine the x value if the y value was 3.8. Also determine the y value if the x value was negative 1. So this has 2 parts of a question. You can look back to question number 3. I suppose we should go back there fairly quickly. Let's do that. And if you backed up, you'll see that we came up with that our slope, remember, was 2.2. I wish it would have put these two together. What we're going to need to find is the equation of the line, so we need another point. I'm going to take, we could take any of these. I'm going to take the point 512, simply because it's whole numbers. Maybe a little easier to deal with, maybe not, I don't know. You could take any ones you want. So what we're going to do is we're going to take a slope of 2.2, this point 512, because we know the line goes through there. We're going to find the equation of the line, and then we'll answer both of those questions from number 8. Okay, so that's what we take from number 3 is the slope and one of the points. Okay, there we are. So then we're just ignoring number 7 at this point. We've already done it. Okay, so what's the equation of this line? The equation of the line is going to be y equals 2.2 x plus b. You'd also use point slope form, but I prefer this way. So what we're going to do is we're going to take the x value, plug it in for x. We're going to take the y value, plug it in for y. So we end up with 12 equals 2.2 times 5 plus b. We're able to do 2.2 times 5, so we get 12 equals, is that 10.1? Is it 11? I think it's 11. It's 11, isn't it? Yeah, it's 11. So then we subtract. Back here. What we're going to do is we're going to subtract 11 from both sides to give us that b equals 1. So our equation, y equals 2.2 x plus 1. And so now find the x value if the y value is 31.8. So we're going to plug in 31.8, solve for x. So let's do the a part. We'll call that the a part. 31.8 is y. 2.2x plus 1. Solve for x. Subtract 1 from both sides. That gives us 30.8 equals 2.2x. Divide both sides by 2.2. What we do is get x is equal to 30.8 divided by 2.2 gives us 14. So that answers the first question. The second question is going to be find the y value if the x value is -1. So that means we're going to put the -1 here in for x. So for the b part, we get y equals 2.2 times -1 plus 1. That's y is equal to -2.2 plus 1. That gives us that y is simply equal to -1.2, combining these two. So there's the answer to the b part. Okay. Let's go on to 9. So for this one, we're given an equation. and we're asked to find simply the horizontal and vertical intercepts. Remember, the horizontal intercept has y equals 0. The vertical intercept has x equals 0. So, to find the horizontal intercept, we're going to take this equation, but we're going to put 0 in for x. 2 times 0 minus 3y equals 12. 2 times 0 is 0. 0 minus 3y is minus 3y. So we simply end up with minus 3y equals 12. To solve for y, we will divide both sides by negative 3. And what we get is canceling here, and we get that y equals negative 4. So our horizontal intercept is going to be the point 0, negative 4. To come up with the vertical intercept, we are going to plug in 0 for x. Wait a minute. I messed up there, but not too bad. This we actually already had. You probably were catching me trying to get me to stop and say, wait, you're plugging in 0 for x, that's the vertical intercept. Okay, I got you now. We did the vertical over here. So that must mean this is going to be the horizontal over here. Horizontal intercept. This one we're going to put 0 in for y. So we get 2x minus 3 times 0 equals 12. Negative 3 times 0 is 0, so we're left with just 2x on this side equals 12. We'll divide both sides by 2, and that'll leave us with x equals 12 divided by 2 is 6. So the point we get is 6 comma 0. So that's the horizontal intercept. Better than restarting, right? Okay, that's number 9. In 2001 my salary was $58,000, and in 2006 it was $64,000. So what I have to recognize here is they're giving me data points with time and salary. Time and salary. So they've given me 2 data points. If we assume a constant rate of change, linear function, then what would be my salary? What would my salary be in 2017? So thinking of a linear function, that's going to be y equals mx plus b. Remember, we know how to get the slope. It's with 2 points. We could find the y-intercept as well, and then we can figure out what year this is and plug it in. So my suggestion is to let 2001 be year 0. Restart the timing. So at the beginning of my job, I was making $58,000. Maybe we shouldn't put in the comma there. It kind of gets in the way. Okay, and then 2006, which is 2001, 2002, 2003, 2004, 2005, 2006. 5 years later, or just take 2006 minus 2001. 5 years later, we're making 64,000. So to find this slope, we simply need to subtract the data values. 0 minus 5 gives us negative 5. 58 minus 64 gives us negative 6,000. And to get our slope, we take the x value, tuck it under the y value, and we get that the slope is 6,000 divided by 5. Negative divided by negative is a positive. I think it's about $1,200. Try it out with a calculator. That means we're getting about $1,200 a month raise. The nice part of choosing the first point to be 0 is that this number here, 58,000, that's our vertical intercept. That's our value for B. So we don't have to do anything extra. We simply have an equation that is y equals 1,200 times x plus 58,000. Now to find our salary in the year 2017, we have to find out how many years it is from 2001 to 2017. And again, that's a difference type problem. What are the difference between 2001 to 2017? If we just subtract 1 from 7 is 6, that's 1, that's 0, 0. So it's 16 years difference. That's what we get to plug in for x. So we're going to write this as y equals 1,200 times 16 years plus 58,000. And that will give us our new salary. So for this one, we'll just, we could say it's going to be about 32,000 more, but not quite. 1,200 times 1,600, or 16. We're going to make 19,200 more than what we started with. What we started with was 58,000. And so we're at 77,200. That's going to be dollars in 2017. Not bad. Not great either, really, but not bad. Okay, so we'll put all of this away. We're going to look at number 11. Let's see, can I come up here? Now, what I'm going to do with number 11, instead of just solving it as it is, I'm going to show you how you would do this if you, on a multiple choice test, because that's what you're going to have. So you would have a couple different options. You would be told maybe an A, a B, a C, a D. What you're going to do is you're just going to plug those values in. So I might give one is, let's see, 5, 4, and if I can remember, let's do 5, negative 4, and let's do, I think, 3, negative 2. I think that ends up working. So what we're going to do is we're going to take the x values, plug them in for x, the y values, plug them in for y, and see if it works. So you could kind of do it visually. So we'll check out the A question. I'll check out the easier one first. I'll put 5 plus negative 4, does that equal to 1? And 5 plus negative 4, yes, 1 equals 1. It checks there. But now let's see if it works in the top function. We're going to have 2 times the x value, which is 5, plus 3 times the y value, which is negative 4, and what we're checking out, does that equal 12? Oops, there's a minus there, not a plus. I think I made this mistake in class too. Someone else caught it for me, but there we go. So this gives us 10. This is a negative times a negative, which is a positive. That's a 12. We can see we're not off. This is 12 plus 10 is going to be 22. Does that equal 12? No. So this one didn't work. Try the next one. Try out B. Put in 3 for x, 2 for negative y, or negative 2 for y. Does that equal 1? 3 minus 2 equals 1. Yes, 1 equals 1. That checked. Let's try the top one. 2, plug in 3 as a value for x, minus 3 times negative 2, and what we're going to check is, does that equal to 12? 2 times 3 is 6, negative times a negative is a positive, that's 6. Does that equal 12? 12 equals 12, yes. So it works in both equations. This is the one that's going to be it. Now there'll be 2 other options, so you might have to try those out, but the ones that don't work, eliminate them. Once you have one that works, you're done. Okay, so that's how you're going to do this one, and there's one like this on the final exam. Okay. Let's take a look at 12, 13, and 14 all at the same time. There we go. Okay, so we're given an equation, y equals negative 2/3 x. Find the horizontal and vertical intercepts. Remember, horizontal intercept, y equals 0. Vertical intercept, x equals 0. So we have the equation y equals negative 2/3 x. Whichever one you want to start with, let's go ahead and plug in 0 for y first. So the horizontal is going to be 0 equals negative 2/3 times x. We need to solve for x, so we multiply both sides by the reciprocal, which will be 3 over 2 negative. Negative times a negative is positive. The 3's cancel, the 2's cancel, so on the left hand side we're left with x. On the right hand side, when we multiply by negative 3 over 2, whenever we multiply anything by 0, we always end up with 0. So when we plug in 0 for y, we get 0 for x. The horizontal intercept is 0, 0. Now you could jump and say, well, if the horizontal intercept is 0, 0, the vertical intercept must be 0, 0, and you would be correct, but let me just go through the steps. We would plug in 0 for x, zero times negative 2/3 is 0, so y equals 0. So when x is 0, y is 0. The vertical intercept is the point 0, 0 as well. Okay, so that's for the vertical, that's for the horizontal. We're given an equation. We're asked to find the slope, the vertical intercept, the horizontal intercept. Again, vertical intercept, we're going to have x equals 0. Horizontal intercept, y equals 0. And then the slope, we're going to want to get it into the y equals mx plus b form, or we could use the 2 intercepts to figure out what it is. So, vertical intercept, 0 goes in for x. So I'm just going to do that up here. Don't worry about this. We get 2 times 0 minus 5y equals 12. 2 times 0 is 0, so we're left with negative 5y equals 12. Divide both sides by negative 5. These cancel, so y is going to be equal to 12 divided by negative 5, which gives us negative 2.4. So when x is 0, y is negative 2.4. 0, comma, negative 2.4. That's our vertical intercept. For the horizontal, intercept, we're going to plug in 0 for y. So we're going to have 2x minus 5, and for the y we're going to plug 0. That needs to be equal to 12. Negative 5 times 0 is 0, so we're left with 2x equals 12. And we divide both sides by 2. I have a feeling we've done this before. Probably that becomes x equals 6. So our horizontal intercept is x is 6, y is 0. Now with these 2 points we could go ahead and find the slope. So we could do whichever one you want on top, 6 comma 0 and 0, negative 2.4. To find the slope, we subtract the points. 6 minus 0 is 6. 0 subtract negative 2.4 is going to give us a positive 2.4. And then we take the x, tuck it underneath the y, and there's our slope. 2.4 divided by 6. Let's go ahead and pull out a calculator on that one. 2.4 divided by 6, both are positive, so we get our slope is going to be 0.4. I'll show you the other way to get at the slope from the equation itself, and you'll see basically it ends up being the same way, but I want to show you the 2 different ways, and if you don't want to see it you can always fast forward. But we take the equation we started with and we're going to solve it for y. So we start off with 2x minus 5y equals 12. We're going to subtract 2x from both sides so that we can get y by itself. On the left side this becomes 0, so we're left with minus 5y equals 12 minus 2x. And then the next step we're going to do is we're going to divide both sides by negative 5. And when we divide that right hand side it has to distribute to both terms. So negative 5 and negative 5. Left hand side, these guys cancel, leaving simply y. 12 divided by negative 5, maybe we did that somewhere, maybe not. Let's 12 divided by negative 5 gives us, no, I subtracted 12 divided by, I have to put 5 minus, that's how we have to do it, negative 2.4. And then negative 2 divided by negative 5 is going to be a positive. 2 divided by 5 is 0.4. Let me do that for you here so that you can see it. 2 divided by 5 is 0.4. 0.4x. And we know in this form the number in front of the x is the slope. So we see both ways slope is 0.4. So we're able to answer that question either way. And it's good if we can do both because just builds up our confidence. Now 14, we're almost there. If y equals 5, find the slope, the vertical intercept, and the horizontal intercept. Again, remember that vertical intercept means x equals 0. Horizontal intercept means y equals 0. And slope is a slope. But for this particular question, y equals 5, we want to understand what kind of a line that is. And I'm going to remind you that this is one of our extreme value lines. It's one of our, well, it's, oops, I guess I could draw it there. Do that one. Here, let's draw sort of a y-axis system. And of y equals 5, if you can remember that, that's going to be a horizontal line at y equals 5. Straight across. That's what y equals 5 looks like. And this will help because it'll show you there is a vertical intercept, but there will not be a horizontal intercept because they're parallel, right? So horizontal intercept, D and E, there's not one. But the vertical intercept, you can see that since this is y is 5, it must be the point x is 0, y is 5. So again, it's kind of simple in some respects, but you have to remember what y equals 5 looks like. Without that, there's not much to work with here. And it really is just something you have to remember what's going to go happen. So what's the slope? Well, there is no increase, there's no decrease, it's just sort of straight across. This is the one that has a slope of 0. So the slope is 0. Now the other thing I can do here to help us, why is y just equal to what happened to the x? Remember, what really happened to the x is that it's got a 0 in front of it. It's really y equals 0x plus 5. Every time you whatever you put in for x, it gets multiplied by 0 and disappears, becomes invisible. It becomes 0. 0 plus 5 is 5. So the end result is just that y equals 5, but it's helpful to remember. If you can remember this part, then you've got something to work with. So either remember the equation that y equals 5 is really y equals 0x plus 5, or remember that it's a horizontal line. Draw the picture, and that should help you in getting both the horizontal, which is undefined or does not exist. There is no horizontal intercept. The vertical intercept is simply going to be 0 comma the y value, and the slope will be 0. Okay, so watch for that. And there's quite likely to be a horizontal line on the test. And I think there's one coming up here with a vertical line, and you'll see that it's similar but different. And since we just talked about it, let's go ahead and jump to 16, then we'll come back to 15. Because 16 is x equals 2. So that's going to be, look at our x and y axis here. So x equals 2 is going to be a vertical line at x equals 2. And we can see again there will be a horizontal intercept but no vertical intercept because they're parallel to each other. And the horizontal intercept will simply be the x value 2 with a y value of 0, because horizontal intercepts are always y equals 0. Vertical intercepts are x equals 0. But see, x cannot be 0 and 2 at the same time. That's why there is not one. D, N, E. And the slope, you'll just have to kind of remember this one. This is the one with infinite slope or undefined slope. Sometimes in Math AS they will list it as D and E, but mathematically what they usually will say that this is undefined. But remember, Little Crow says that is really an infinite slope, infinity. Okay, but we really had to understand that that was x equals 2. That's what's going to give us a vertical line. Now we'll do one, we'll come back to 15. I think I'll go ahead and leave this here. 15, we've got an equation. We want to find the slope, vertical intercept, and the horizontal intercept. Remember, vertical intercept, we plug in x for 0. Horizontal intercept, we plug in 0 for y. The slope is going to be the number in front of the x as long as we have it in the form y equals mx plus b or y equals b plus mx. And hopefully you notice that it's in this second form. So our slope is going to be the number in front of the x, which happens to be -3. So we just out of the gate, slope is equal to -3. We got that answered. Also remember the value of b, that's our vertical intercept, because if you put in 0 for x, -3 becomes 0. 0 times -3 times 0 is 0. So you ended up with y equals 2. So by doing that, you get the point x is 0, y is 2. So that's why we like this form. It's got our slope there and our vertical intercept. Now if we need to find the horizontal intercept, which is asking, we will plug in 0 for the y, and then we will solve for x. Okay. So the first thing we do is to get x by itself. We will subtract 2 from both sides. And then we will divide both sides by -3. What we end up with x over here, and we end up with a positive 2/3 over there. So that's what x is. Y was 0, so the horizontal intercept is going to be the point 2/3, 0. And there we have it. Okay, 2 more questions. Almost to the end. And then we're ready for the final exam. So now we're going to be, I think we've kind of done ones very similar to this so far. We're asked to write this equation in slope-intercept form. Okay, so that means we're looking, slope-intercept is simply y equals mx plus b. We're trying to get y by itself. So we start off with 2x minus 5y equals 12. We are going to get y by itself, so we subtract the 2x from both sides. It cancels out here, 2 minus 2x, 2x minus 2x, so we have -5y. You could put the x in front. I'll do it that way this time. -2x plus 12, or if you want to write it as 12 minus 2x, that is okay too. And the last step to do is to divide, because this is -5 times y, divide by -5. And when we divide more than one term, what we have to do is we have to distribute it to each of the terms. So we get this to cancel. We get y equals a negative divided by a negative is positive. You could leave that as 2/5 if you'd like. And you could leave that as 12 over 5 if you like. So that's one way to write this, except you better leave it negative. Negative divided by positive is a negative. Oops. Go with this. Or you could divide them. That just depends on how the answer is written. 2 divided by 5 is 0.4. And 12 divided by 5, if you'll remember, is 2.4, or just use the calculator and you're fine. And that's the question. That's all we had to do. Again, we did this earlier, and we were able to see that 0.4 is the slope, and if you need it, -2.4 is the y-intercept. Okay, let's go ahead and make a copy of that. And see if I can get a little bit more room. I think I might need a little more room. Okay, so Let's look for our numbers. $2 for children. Tickets to get on a bus are $2 for children, $3 for adults. The bus can hold 60 people, and we've got a total revenue of $140. So we let X and Y, if you want, we don't have to use X and Y, but why not? Maybe X can be equal to the number of children. Could use C as well, and then we'll let Y equal, so not just children, but the number of children, not the cost of the children, but the number of children. Y will be the number of the adults. There we go. First of all, we know that the bus will hold 60 people. They will be either children or they're adults. So the number of children plus the number of adults is equal to 60. The costs is going to be each child will pay $2, each adult will pay $3, and the total cost is $140. So that's the setup. Sometimes you'll get a question that just asks you to set it up on the final exam. There is one like that, just kind of reading the question, set it up. So if that's all that it was asking, we would have been done. But this particular one then wants to know how many children and adults got on the bus. So for this one, again, that would probably give us the answers, and so we could plug it in for X and Y and check which one worked. But I'll show you this last one, since it's the last one we'll be doing, how we can do this. What we'll do is we'll solve one of these equations. We'll solve the first one for X or Y. You could do it either way, but notice we could subtract Y from both sides so that we get a new equation that is X equals 60 minus Y, right? Because Y minus Y, that's going to be 0. That disappears. 60 minus Y. So we can use this equation. Then what we're going to do is we're going to take this form of X and we're going to plug it in for this X over here. Okay. That will give us an equation with just Y. We will solve for Y, and then we'll be able to solve for X. So what we're going to do is we take this second equation down here. But instead of using the X, we're going to use another form of X, because these X's are the same. Back to plus 3Y equals 140. And we should hopefully remember we're going to need to distribute this 2 to both of these terms. So that's going to give us 120 minus 2Y plus 3Y equals 140. We can combine like terms, these y's, 3y minus 2y, so we get 120 plus 1y equals 140. Solving for y, we subtract 120 from both sides, and we end up with that y equals 140 minus 120, 20. That's the number of adults. So then what we do is y is 20, so we take this equation here, we get x plus 20 equals 60. Subtract 20 from both sides, and we end up with x equals 40. So 40 children, 20 adults. Okay, so that's the last one to do. Again, on the final exam, it'll be multiple choice, so they'll give you different values of children and adults. You can plug them in, but you will need to be able to come up with this equation to solve it. Okay, so good luck in your studies. Watch the video as many times as you need. If you have any questions, give me an email. Ask for what you need. If you want to look at some other problems being worked, I would be happy to do that. So looking forward to seeing you for the final exam. Thanks. Oh, better take a picture of this. There we go.